Figure 7.23 through 25, gradebook using a two-dimensional array to store grades. Now that we've shown you how to work with two-dimensional arrays in C++, we're going to modify the gradebook class one last time to represent a set of students and their grades across 3 exams. So here is the main function for our program, and as you can see here, we're declaring a two-dimensional array called GradesArray, and in this version of the gradebook class we have 2 constants that are declared as static constants in the gradebook class. Students represents the number of students, and tests represents the number of tests per student. So we're going to have students number of rows and tests number of columns, where students is 10 and tests is 3, and you can see as I hover over these that it's happy to tell me what these constant values are. Now we have a initializer list, a multi-dimensional array initializer list, where each sublist represents 1 row in the array. So what we've done here is we've hard-coded the grades for 10 students across 3 exams. Now, just like in the last version of the gradebook, we're going to create a gradebook object passing in the name of the course and the array that represents all the grades. This time, however, it's a two-dimensional array. And then we're going to display our welcome message and process the grades. So it looks very similar to the version of the program that used this one-dimensional array. Now let's take a look at the output window first here to see what's going to happen. We're going to, of course, display for you all of the students' grades, but as part of doing that, we're also going to show you a 4th column, which is the average for that student. So student 1's average was 84.33, student 9's average was 77.33, etc. Then, after we've displayed this table of grades, we're going to show you the lowest grade of all of the grades in this two-dimensional array and the highest grade in the array. And once again, we'll show you a grade distribution chart. Now, the techniques that the code rather, that we're about to look at use very similar techniques to the previous version of the gradebook. So I just want to focus on the kind of two-dimensional array aspects of this example. So let me open up the gradebook.h file here, and you can see right away that in this example we have 2 constants that we've defined. Students is 10, tests is 3. And our gradebook constructor has been modified to expect to receive a two-dimensional array where the second dimension is 3, as in there are 3 columns per student, there are 3 tests per student. At lines 19 through 27 we have the other public member functions, and what we have here hasn't really changed much from the last version of the gradebook, with the exception of getAverage, which is now a new function for us that we're going to be calling from the output grades function so that we can calculate the average for a particular student. And for this function, we're going to pass to it a one-dimensional array of integers and the number of elements in that array. And then finally, we have our private data, which now consists of the string course name and the two-dimensional array, the rows and columns for the grades array, which has student number of rows, 10, and tests number of columns, 3. So let's take a look at our implementation. And again, most of this is very similar to what we just looked at. A key difference in the constructor is that we're now expecting to receive a parameter which is a two-dimensional array of integers, and that has some number of rows and tests number of columns. We set our course name, and the key difference here is that instead of a single for statement to copy the elements from the parameter grades array into the array called grades, we now have a nested for loop, one that counts which row we're on and one that counts which column we're looking at, and then for a given row and column we copy it into the corresponding row and column of the grades array. Set and get course name have not changed, and display message has not changed. Process grades is very similar to the last program. We output the grades, then we output the minimum and maximum grade in the gradebook, and then we output the bar chart. The one thing that's missing from the last example is you don't see anything here about calculating the class average, and that's because in this example it's going to happen in the output grades function. Get minimum, very similar concept to the last example. The key difference is that now we have a nested for loop, so we walk through every row and every column of the grades array looking for the lowest grade. And similarly, get maximum, It uses the same basic techniques as the last version of Gradebook, but it uses a nested for loop to walk through all the rows and columns. Get average is interesting because when get average gets called, we have to pass it a one-dimensional array of grades, and we don't have one-dimensional arrays in this example. So before we look at the code for this, let's go look at the output grades function. And you can see here for the output grades function that we're going to output a heading and then some spaces to help us align our column heads. And then we're going to output the word test, and then test plus 1 is the value being output. So we're going to output test 1, test 2, and test 3 as our column heads, and then average as a column head as well. And then we have a little for loop here which walks through the rows of our grades array one student at a time, one row at a time. And for each row we output the string student followed by the student number 1 through 10, where student is 0 through 9 and we're adding 1 to it. And then we output the grades for each of the columns. So we're going to, in a field of 8, output a grade, and we're going to do that for each of the columns in this current row. And here's where we call get average. And notice what we're passing to get average. Grades sub student. Now grades is a two-dimensional array. Grades sub student is actually telling get average which row of the two-dimensional array to look at. And then within that row, tests is saying how many elements are in that row. So when get average gets called for a particular student, we go directly to that row of the grades array, and get average then loops through that row of the array, taking each element of the array and adding it to the total, and returns the average for that student. Then back down to here, we store that average and display it on line 175 as a fixed point floating point number with 2 digits to the right of the decimal point. And notice that it's right justified in a field of 9 characters. So the interesting thing about the get average function is that even though we don't have one-dimensional arrays in this program, you can treat the individual rows of a two-dimensional array as if they are one-dimensional arrays unto themselves. You just need to make sure that you process the right number of elements so that you get the logic of your program correct. And then finally, the last piece of this program is the output bar chart function, and the key difference in this example is lines 127 through 130, where we have to use a nested for loop to walk through all of the grades in the grades array, incrementing the appropriate frequency counters each time.